Welcome to my algebra class. We're on chapter 10, section 3. We're going to be using inequalities to solve word problems. And the wording is important. If you see words like is at least, then that's the inequality greater than or equal to. Is no less than is greater than or equal to. Is at most is less than or equal to, and is no more than is less than or equal to. And of course, less than and more than. Here's an example. Mike wants to rent a car for his vacation. The rental cost is $150 a week plus 20 cents a mile. How far to the nearest mile can Mike travel if he wants to spend at most $250, and he's going to be gone for 1 week? So X would represent the number of miles he could drive, and here's our equation: 150 plus 20 cents for every mile he drives, so 0.2 times X. And he doesn't want to spend any more than $250, so it's less, at most is less than or equal to $250. So we solve the inequality, subtract 150 from both sides. We get 0.2x is less than or equal to 100, divide by 0.2, and we end up with x is less than or equal to 500. So at the most he can drive 500 miles. So we'll be using those to solve our problems, and we're ready to start. We're on page 473. Head your papers, skip a line, put the title, fold it, and we're starting with number 2. It says a house and a lot together cost more than $89,000. The house costs $1,000 more than 7 times the cost of the lot. How much does the lot cost? So if we let x equal the lot, since we read, if we read the problem, you can see the house costs $1,000 more than 7 times the lot. So the house costs $1,000 more than 7 times the lot. And together they cost more than $89,000. So the lot plus the house is more than, that's greater than, $89,000. Collecting like terms, x plus 7x is 8x. Solving for x, subtract 1,000. And we get 8x is greater than 79,000. And then divide by 8. So x is greater than Yeah, I had a mistake here. If I take, I wrote the numbers wrong, so let me fix that. This should be 89,000. And if I subtract 1,000 from that, I'm obviously not going to get 7,900. That would be 88,000. So x is greater than 11,000. So how much does the lot cost more than $11,000? Problem number 4. Jordan's salary is $1,250 a month plus a 5% commission on all his sales. What must the amount of his sales be to earn at least $1,500 each month? So if X stands for the amount of cells, his salary is $1,250 plus a 5% commission, change that to a decimal and be 0.5, on all his sales, X. And he wants a salary at least of $1,500 a month, at least. So it could be more, so greater than or equal to $1,500. Solving, subtract 1,250 from both sides. We get 0.05x is greater than or equal to 250. Divide by 0.05. And x is greater than or equal to 5,000. So he has to have 5,000 or more of sales. Problem number 6. The sum of two consecutive even integers is at most 400. Find the pair of integers with the greatest sum. So if x equals the first even integer, then x plus 2 is the second even integer. And it said the sum of the two, so 2x plus 2, I'm just adding them together, is at most 400. So it can't be more than 400, so at least it could be 400, but less than. So if I solve this, subtract 2 from both sides, I get 2x is less than or equal to 398. Divide by 2, and I have x is less than or equal to 199. So I want the first pair of integers with the greatest sum. So the very first even number under 199 would be 198 is my first even integer, and then add 2, it'd be 200. So if I added those two, that would give me the largest sum less than or equal to 400. Problem number 8. Between them, Terry and Shelley have 50 cassettes. If Shelley has more than 2/3 as many cassettes as Terry, at least how many cassettes does Shelley have? So if x equals the number of Terry's cassettes, then 50 minus x, because there's a total of 50, equals the number of Shelley's. Then it says if Shelley is 50 minus x, more than, that's greater than, 2/3 as many as Terry has, 2/3 x. So I'm going to multiply both sides by 3 to get rid of the fraction. So I have 150 minus 3x is greater than 2x. Adding 3x to both sides, I get 150 is greater than 5x. Divide by 5, and I get 30 is greater than x. Therefore, x is less than 30. So at least how many cassettes does Shelley have? Well, Terry has less than 30. So if I take 50 at the least, how many could she have? Take away 29. The most that Terry could have would be 29. Less than 30 would have to be 29 for Terry. And the most that Shelley could have, if I take 29 from 30, would be 21. And problem number 10. Ken has 22 coins, some of which are dimes and the rest are quarters. Altogether, the coins are worth $3.40. At least how many of the coins are quarters and how many are dimes? Well, if X equals the number of dimes, then 22 minus X equals the number of quarters, since together they have 22 coins. And we know the value of the dimes is 10 cents, so 10x is the total value of the dimes, plus 25 times 22 minus x is the value of the quarters, and it has to be more than $3.40. So I'm going to use 340 cents since I used 25 and 10. So this is 10x plus 25 times 22 is 550 minus 25x is greater than 340. Collecting like terms, I get 550 minus 15x is greater than 340. Solving for x, subtract 550, and we have negative 15x is greater than negative 210. Divide by negative 15. And we get 14. So x is greater than 14. And they asked on number 10, at most how many are dimes? And at least how many are quarters? So if x is greater than 14, that would be 15 dimes. Yes. Okay, I forgot to turn the inequality around, so this should be less than 14, since I'm dividing by negative 15. So the number of dimes is less than 14, and that would make the number of dimes equal to 13. And then 22 minus 13 would be 9 quarters. So 13 dimes, 9 quarters. Since they asked for the most dimes. And the last problem, number 12. A pair of consecutive integers has a property that 7 times the smaller is less than 6 times the greater. So if x equals the first integer, and they're consecutive, so x plus 1 equals the second. And it says the 7 times the smaller, which would be 7 times x, is less than 6 times the greater. So working that inequality out, 7x is less than 6x plus 6. Subtract the 6x from both sides, and we get x is less than 6. So what are the greatest such integers? Well, the first number underneath 6 is 5, so that would be 5 and then add 1 6. 5 and 6 would work. That concludes the evens. Be sure you check the back of the book for the answers to the odds.